We're now going to take a look at programming and security. Programming languages are used to create programs that solve some particular problem. Now, before someone writes a program in a programming language, they typically create a plan to solve it in a normal language like English or a natural language. And this solution they come up with in the natural language is called an algorithm. And basically that explains step by step what needs to happen in order for the problem to be solved. We then write the program in the programming language by following that plan that was laid out in the algorithm. And the process of doing this is called coding. So we have to understand the problem, devise a plan to solve it, which is our algorithm, implement that plan, which is our coding, creating the program from the algorithm, and then evaluating the results of that particular program to see if it's giving us what we want. Even though we have created the program, the computer still can't understand what we've done, because basically the computer only understands zeros and ones, or voltage, no voltage. So a translator program must convert the program we've written into what we call machine code. Machine code is the computer's native language, and it looks sort of like what's on this slide. 0, 1, 0, 0, 0, 0, 1, it's a whole bunch of zeros and ones. Now, any errors that you've made in the program code in order to get to this stage are called bugs. And the reason for that is a long time ago when they were working with computers, there was a system that had a moth get in and caused trouble with one of the relays, and therefore it caused the program not to work. And so ever since then, when we talk about fixing your program so it works properly, we talk about debugging the program so that it will do what you intend for it to do. Every program must have a particular syntax or structure. Now, every language has a structure or a syntax, and English, as an example, you would say, here comes the brown cow. You wouldn't say, brown comes the cow here. Now, it is possible to create a language that could use that structure. There's nothing wrong with that structure necessarily. So you could say, red and yellow flew the bird brown over the fence, which in English would read, the red and yellow bird flew over the brown fence. But the point is that no matter what language you're talking about, whether that's a human language that we use to speak or a programming language, there must be some flow, some structure, or syntax to that particular language. Programming languages use control structures, which are logical structures that control the order in which instructions are to be carried out. And some of the main ones are the sequence control structure, selection, and repetition. The sequence control structure determines the order in which the instructions are to be carried out. And normally this is from the beginning or the top command and working its way down through the different instructions. The selection control structure allows you to, or the computer program, to select between a number of choices using a particular condition. So, for example, if x is greater than y, do the first option, otherwise do the second. And here's a coding example of that. If x greater than y, then print yes, else print no. The other control structure is a repetition control structure, which keeps repeating a process until a particular condition is met. So we could keep repeating something until x equals 5. If we see in the code here, repeat x equals x plus 1 until x equals 5. Only danger here is if we are not careful, the way that is set up, we could have started out with an x that's greater than 5, and therefore we would have created an infinite loop, which is something we want to be careful about when we're creating our programs, because it would just stall the system and stall the program. There's two general categories of programming languages, procedural and object-oriented. Procedural programming languages are written out in a sort of a long book-like fashion, and some of the more common ones include QuickBasic, Pascal, C, Fortran, and COBOL. Now, QuickBasic stands for Quick Beginners All-Purpose Instructional Code, and that's basically just a language for beginners that just wanted to learn how to program. Pascal is a bit older, and it was often used to teach computer science students in university how to write well-structured programs. Some other procedural languages include C, which was designed to work faster than other programming languages, Fortran, which is an older one, used to solve particular formulas for scientists, and COBOL, Common Business Oriented Language, which was created for use by business. The other category of languages is object-oriented. And object-oriented programming languages are written inside of objects they display, and some of the more common ones include Visual Basic, C++, and Java. Now, Visual Beginner's All-Purpose Instructional Code, or Visual Basic, uses some of the object-oriented features to make program easy, although it doesn't go the full step. So you are using objects, and you are having those objects interact. C++ is basically the C language plus some object-oriented features, and Java was sort of built from the ground up to be an object-oriented language that will work well with the web. We're now going to take a look at security. So in this section, we're going to look at different types of computer crimes and how to improve security and what you can do to protect yourself. Now, it may be surprising to learn that most of the computer theft that happens with regards to companies is done by the company's own employees. And the reason for this is that they typically have access to the company's computer systems more, and the things that they take, money, equipment, software, even processing time. Now, legally, the company that you work for owns the computer, and any unauthorized use of that computer, such as doing your own personal taxes on it, could be considered to be theft. But in most cases, that wouldn't be a huge issue. So I'm sure that most employers would not be that upset if employees were using the computer to do taxes on, not on company time, but on their own time using the computer resources. But just so we understand that the major source of theft with regards to computer resources is typically the company's own employees. Now, when we have information in a number of different forms, whether that's picture, text, and so on, and we copy that information when it has a copyright on it, then that duplication is illegal. And so if we take a particular document and we do the copying electronically, there really isn't any difference between doing that and copying it using a photocopier. The other thing that sometimes software programs will do, especially games, is put on particular protections that codes and things that have to go in to help prevent people from copying those particular programs. But typically those get broken. And the ones that you could copy legally would be programs or information that's in the public domain, and that information is no longer held under a copyright. Software piracy is the unauthorized copying of a computer program. Even using a copy made by someone else is a crime. And currently, this isn't prosecuted too much, except for those that are running off, many, many copies of programs. However, as companies are checking these things now on the internet, they can see what version you're using, and so they're using these types of systems in order to figure out who has legal and who has illegal copies. Counterfeit is taking money or documents and duplicating them to pretend that they're the real thing. This has become a lot simpler with more advanced scanners and high quality color printers. Now, money is constantly changing, as an example, and being redesigned with uncopyable features, and there's even some photocopiers that place invisible codes on documents so that anything that's copied on them could be traced back to a particular system. Software sabotage is the creation of software programs that performed some type of illegal acts. Data diddling is altering information on a computer system in some unsanctioned way, like altering marks on a school's computer or modifying payroll records. They say that Bill Gates actually changed the class roster so that he could get in classes with some of the pretty girls. I'm not sure if that's true or not, but if it was true, that would be considered to be data diddling. Salami shaving, on the other hand, is when small amounts of something, could be money, could be even points, is deducted from a larger number of transactions, and the results are then accumulated illegally. It could be money that this happens to, but lots of stores now have reward system, point systems, that can be redeemed for merchandise. So it is possible that someone could collect extra points and then use those. and that would be a case of salami shaving. A Trojan horse is a program that appears to perform some useful function but may actually damage your computer's information. So for example, you download a program, you think it's a Pac-Man type game, and you're sort of gobbling up these little bits, and what you don't realize is it's actually in the process of reformatting your hard drive while you're playing that particular game, and that would be an example of a Trojan. Viruses are programs that are designed by someone to copy themselves from one computer to another, and in the process they'll alter or destroy information on the different systems that get infected. Some of them are fairly benign. I think there was one on the Macintosh one time that would just come up and say happy birthday to me, happy birthday to me. But some of them are fairly dangerous and can do a significant amount of damage. Now, a worm is a little different than a virus in that they not only will spread from system to system in a passive kind of way, but they will also try to infect systems and actively break into those other networks. So they'll actually do a little bit of research and checking around to try to figure out the best way to break into a system based on maybe the information they can find about who is the operator of that particular computer system. So worms are a little more pernicious, and they can spread very, very quickly because they're actively trying to propagate themselves. A logic bomb is designed to go off at a specific point in time or when some particular operation starts. So one example of that was in the States, in New York City. There was a disgruntled employee that worked with the computers. He actually put a logic bomb on one of the printer fonts. So when someone actually went to print out a particular document, they accessed a font, which then loaded the logic bomb and set it off on the computer system and basically took down the power grid in New York City. Fortunately, they were able to figure out what was happening in time, and they shut the entire system down and were able to start it up again without any problems. Now, there's a difference between hacking and cracking. Hacking is spending large amounts of time working with computer systems and maybe trying to break into another computer system. The term comes from computer science students that used to sit around spending almost all their waking hours typing and hacking away at the keyboard. Cracking is a little different and more serious. It's breaking into computer systems to damage or to steal computer information. So a hacker might just be looking around, just seeing what they can do, but they're not really trying to cause any trouble necessarily. Crackers are really trying to break into stuff, to do some damage, steal some information. A sniffer program could be used by a cracker to try to intercept codes on the network so that they're able to then get access to files or resources on that particular network. Copycat websites can occur on the internet. They are made to look like real commercial sites, but when you purchase anything from them, they'll basically steal your credit card number. Other internet issues include internet stalking, where the person that's doing the crime will meet someone in a news group or chat room. The victim is targeted and arrangements set up for a real-world contact. So it's always good to be very careful about the kind of information you reveal on the internet. And cyber pornography is the distribution of pornography on the internet, which is also a huge problem. There's a difference between what we call public-coded and shareware. Public-coded software, you are able to copy and modify it, but it must remain open source. Shareware lets you try the software, and if you like it, then you can purchase it later. It used to be that public-coded software wasn't at the same level as some of these packages that you could buy, but open source, public-coded or open source software, which is what it's called more often now, is getting better and better all the time. And in fact, some of the programs that I'm recommended that you use in this course have been open source. So there's lots of risks out there with regards to computer systems, and there's some risks for you just as a person. So what are the ways that we can help reduce some of these risks? Well, number one, you can be careful who you hire, especially with computer types, because they tend to be the ones that are given the power over networks. It's often a good idea to implement physical access restrictions. So to be able to get on the network, you need a password or a card or some type of fingerprint. You can separate employee functions so that maybe no one has too much of the power. So you want to make sure that there's not one person that has so much power and could do so much damage before you could actually figure out what was going on. Other ways to reduce risks include building firewalls that would guard against unauthorized access to the computer, and some firewalls will pretend to give a person access after a certain number of tries, but then they'll try to trace where that person is actually coming from to break into the system. Another thing that's possible is to use encryption, the scrambling of characters on any sensitive information, so anyone who might actually intercept it can't read it without a decryption key. As well, it's important to do periodic audits of a system to make sure everything's working correctly. Of course, always, always, always back up system information and be very careful about the kind of things that you download. Always think twice before you download a file onto a computer system in case it may contain some type of virus. On a more personal level, some things to think about include surveillance. Sometimes computers are used to monitor employees, and this results in loss of privacy. Some companies use active badges to figure out exactly where their employees are in the building at all times. In fact, some workers get so annoyed they actually pin their badges to the monitors so they could actually take breaks when they needed to. But surveillance is certainly an issue as more and more cameras are being put up even on the roads, subway systems, in different places. I've already talked about how public email is, but one more word of warning. If you work in a company, it's even worse than normal, because email eavesdropping by company officials on your messages is perfectly legal. Now, most companies will say, no, we never would do that. But courts have looked at it and said, well, really the email system is the company's property. And so basically some of the rulings that have come down have indicated that the messages are theirs to look at as well. So most companies not only do it, but will try and conceal that fact from employees if there was some issue. So you can almost be guaranteed if there was some legal proceeding or some issue with regards to you, that your email would be opened fairly quickly. So don't say you haven't been warned. I'm just telling you that whatever you put in email, consider that sort of public, just sort of like writing on the outside of your door on a message board, and that if you want to keep something private, then put it in a letter, seal the letter, put a stamp on it, send it to somebody that way, and that will maintain a much higher degree of privacy. One of the newer threats to privacy comes from marketing databases, and basically these are come from the electronic trail you leave behind when you purchase things, and they can be compiled in different ways from different types of cards that you might be using. Micro-marketers then compile and analyze that information, sell it to other companies. So every time you're using your credit cards, your point card, you're giving somebody the opportunity to compile more information about you. So you just always think about what it is that you're doing with these particular cards. And sometimes you want to mix and match with regards to exactly what you're using to make purchases. You want to protect your electronic self. In today's digital society, we're no longer just flesh and blood. We're also an electronic body of information. And that information, in some respects, is more important than the physical you. Now, I mean, it's not really more important, but it's more important with regards to some of these computer systems that are out there. And it's also very vulnerable, because identity snatchers can come and take your identity away and then use your information to run up all kinds of debts and create all kinds of hassle for you. So that we have to think about some ways that we can protect ourselves. So how do identity snatchers do this? Well, they do it in a number of ways. They can alter your mail, send it to a different location without you knowing what's going on. They can use that information to create an electronic you. They might reply to credit cards that were meant to go to you. They get loans. Any credit cards they've got will be used to obtain merchandise and cash and so on. And even if you're able to prove that you weren't the one that created the debt in the first place, it's really difficult to clear your credit record without a big fight. So it's important to try to protect yourself at all possible and keep as much information as private as you can. It's also a good idea to check your credit report regularly. There's even companies now that you can pay a fee, and they will give you updates of any suspicious activity that might be happening with regards to your credit accounts that might be opened, new credit cards and things like that. How would you keep information private? Well, you want to try to not give out your SIN or social insurance number unless absolutely necessary. You can request that information be removed from some databases. I mentioned before you could do different methods of payment. And if you do subscribe to different magazines and things, I like to use a little different variation on the name. And if you tell them not to give your information out and then they do give it out, you're able to catch them because you can realize that there's a different letter in your middle name or something. And that's one way that you can trace who actually is selling your information. You can get a credit report from someone like Equifax. They'll send you the information. And if you are in the unfortunate situation of having someone steal your identity and running up some big bills, basically you have to first of all prove that you didn't do it, which is a major hassle. But the second part of the process is to get a new social insurance number. And it's not always easy to do that, but the only way to separate you from your electronic self from what's happened is to sort of really become a new electronic person, which is basically your social insurance number. So that's what you got to do. Now you might say to yourself, well, why would I have to change my number if they caught the person who did it? Well, you have to do that because computers aren't going to forget. Even if they have caught the person, unless that SIN is changed, everything will still be connected to that social insurance number. So you can explain to the bill collectors it wasn't you, but they're going to believe the computers. They're not going to believe you necessarily. So you just have to make sure that you get that. And also, even if you get it, you have to make sure that the credit bureaus don't copy your old information to your new social insurance number. I mean, it's really, really, really a pain if this type of situation happens to you. So no one is immune to this type of thing, and if they can't catch the person, then a SIN is the only way to take care of it. There's no real way to stop this kind of thing from happening. Today's information society, we're all much more vulnerable. If somebody really wants information, they're going to be able to get it. Well, that basically brings us to the end of the course, and I certainly hope that you enjoyed the course and that you're learning a lot of information. I certainly have put a lot of time and effort into it, and I hope that you are getting the benefit of that. So there you go. That's the end.